Good evening, everyone. Welcome to the AWS Pretoria meetup. Our topic for today is AWS Fundamentals. My name is Roger D'Souza. I'm the Enterprise Security and Automation Practice Lead at CA Southern Africa. We do solutions for enterprise software solutions from CA Technologies, which has now been acquired by Broadcom. So, in the ITSM API management space. So, I have about 15 years of experience in IT service management, in enterprise security, API management, and some development experience as well. Okay, let's switch over to the agenda. The agenda for today's meetup is we'll walk through the AWS global infrastructure. What this is essentially how AWS structures its cloud infrastructure. So that users can consume this, and how it is architected, and how the different components fit together. Then we will cover the virtual private cloud. I will introduce what is a VPC. I'll compare it with a traditional data center. Then I will also discuss the building blocks of a virtual private cloud and what resources are contained within the VPC. The topics that we'll cover today is IP addressing and subnets, how to set up an VPC, internet gateway, NAT gateway and NAT instances, security groups and NACLs, or network ACLs. We'll also cover VPC peering. And if time permits, we will go through transit gateway as well. The approach to this webinar will be, first I will start off with a presentation, which will be about 15 minutes, followed by a demo for the rest of the time. So hopefully the demo gods are with me. Okay, so AWS has a. I will switch back and forth if between the slides and some web links in order to just illustrate how AWS actually structures its global infrastructure. If you have a problem with that, just let me know, then I will just stick to the slides. So AWS has data centers in different regions. The way the cloud is structured, the AWS cloud is structured is they are divided into regions. Regions are basically geographical area. Say, for example, Cape Town is a region, North Virginia is a region, Singapore is a region, Mumbai is a region. So they are geographical areas. And within a region, you have one or more availability zones. So what is an availability zone? Essentially, it is one or more data centers within a geographical area. So for example, in Belleville, or there might be an availability zone with 3 or more data centers within that availability zone. In addition to that, AWS also has edge locations. What is an edge location? Essentially, AWS deploys some infrastructure at some of the cloud providers like Terraco or over here. These edge locations are usually in close proximity to large populations. And the objective of having these edge locations is so that caching and cloud front services can be provided from there. So it's extremely fast. That's the core objective of having edge location. Nowadays, there are other services like Lambda at Edge, which allow Lambda services to be run on at edge locations as well. So what I'm going to do is I'm just going to also show you how the AWS global infrastructure is structured. So if you go to infrastructure.aws, that's where you will actually know about the global infrastructure, how it is structured. So basically, you can actually zoom in to different parts of the world and then see how. So for example, I'm going to click on Cape Town to see what is available at Cape Town. So currently, Cape Town just went live, I think, about 2 or 3 months ago. There are currently 3 availability zones. Now, like I said before, an availability zone can have 1 or more data centers. So there is apparently, according to AWS, there is a sweet spot on the number of servers and infrastructure they can develop, they can deploy into these data centers, something in the order of 300,000. So it's a huge number of servers that they can deploy. So essentially what you do is a region, you can zoom into the region if you go to this, and then you can see how many availability zones, where they have points of presence. And AWS uses its own cables to connect these different data centers within these availability zones. They use transoceanic cables, so they have their own private network that is connecting these data centers. And these are almost 10 gigabit Ethernet cables or even higher, based on the advancements in technology. So when you're sending traffic between regions, in all likelihood, the traffic between these different regions will be on the AWS network. It will not go onto the public internet. Okay, so this is quite a nice website to actually visualize how the AWS and global infrastructure is structured. So you can actually look at regions, availability zones. They have also come up with a new concept called local zones. Essentially, again, availability zone very close to higher population. I think there is only one local zone currently deployed in Oregon. And then they also have different points of presence and edge locations, like I described earlier. So there is this, if you get time after this webinar, there is this talk from James Hamilton at the AWS 2016 reInvent. James Hamilton is one of the VPs and distinguished engineers at AWS. He's responsible for basically setting up the data centers. And it's a beautiful talk in the sense he describes all the challenges they face when setting up the data centers, how they structure their infrastructure, what kind of chips and servers they use in the infrastructure, like the AWS Nitro platform and so on. So it's a very interesting talk. I would highly recommend that you go through that if you do have time after this talk or whenever it's possible. So this is essentially James Hamilton, and he's describing an availability zone, and he says there is one or more data centers. Now, within a region, say for example, if you take Cape Town, they are, like you saw on the website, they are essentially 3 availability zones, and those availability zones can potentially have one or more data centers. So this is some statistics about the current state of AWS infrastructure that I picked up from their website. They have 24 launched regions, 3 announced regions, and 77 availability zones. Remember, the number of availability zones will always be higher than the number of regions. The reason being, one region can have one or more availability zones. Excuse me. So what is AWS Virtual Private Cloud? So if you want to visualize it, it's like a logical container. I mean, it's like a logical container on shared infrastructure. So essentially, there are several users of a public service, and they are sitting right next to each other. But you want to ensure that consumers of the service have an impression that they have access to the specific container, and they can't see resources that other users have provisioned. So it basically allows you to create sort of your virtual network in the cloud. This is a very powerful capability, because what you're doing is essentially you're setting up your network infrastructure very similar to a traditional data center infrastructure in the cloud. And the way you provision routers, switches, and all local infrastructure on-prem, the same way you can go about doing it in the cloud. The only difference is where it would take months, weeks, or months to provision physical infrastructure, it will take a matter of minutes to provision virtual infrastructure. So a VPC is a regional construct. So for example, you can have a VPC in Cape Town that spans all the 3 availability zones within Cape Town. So you have And there is a convention that is followed by AWS when they specify these availability zones and regions. So, for example, the Cape Town region is AF South dash 1, and then availability zone A, B, and C imply the 3 availability zones. And remember, each availability zone can have 1 or more data centers. And according to James, there are about 60,000 servers that can be provisioned in one data center. So, and the sweet spot apparently is 300,000. So about 300,000 in one availability zone, about 300,000 servers can be provisioned. Now, the VPC can be provisioned on dedicated or shared infrastructure. In the past, if you provisioned it on dedicated infrastructure, you couldn't actually switch to or change the tenancy to shared infrastructure. Why would you need dedicated infrastructure? There might be some compliance requirements. Previously, HIPAA had a requirement. For example, HIPAA is a health insurance act in the US, and they had requirements around provisioning virtual resources on dedicated infrastructure versus shared infrastructure. But apparently in 2017 that changed. So you can switch between dedicated and shared infrastructure once a VPC is provisioned. Okay, so how do you go about provisioning a VPC? So essentially, it is a logical construct, and you create a VPC. You log into your AWS account, you go to a specific region. Remember, VPC is a regional construct. So you go to a specific region and you create a VPC over there. And then you add subnets within that VPC. And when you're adding those subnets, you determine which availability zone you want to add that subnet in, and then go about provisioning the VPC. There are other constructs as well, other components that are included in a VPC. So when you create your own virtual network, you want, for example, access to the internet. You may or may not want access to the internet. That is based on your business use case. But if you do want access to the internet, what you do is you provision an internet gateway, and then you attach it to your VPC. Like a traditional data center, you have tiers. You have, for example, a DMZ, which is sort of unsecure. And then you have your internal network and your database tier that is very secure. So you want to actually structure your network infrastructure in the cloud in similar manner, and then have security controls between the boundaries of these different network layers implemented, so that you can control and manage access, and it's much simpler to do that. So in order to do that, you would create subnets, and then you would put your servers in those subnets, and then you would control at the network firewall how access is granted to that subnet, and so on. Similar principles can be adopted in the cloud. So for example, you don't want internet access to your database tier, because you don't want external users to be able to access your database directly, right? So what you would want to do then is maybe create a subnet for your database, or create a security group for your database, and then control access to the database using that subnet and security group, right? So there is another talk by this guy called Colum. He speaks about how Amazon implements VPC under the hood. He speaks about these Blackfoot edge devices that actually, when your VPC traffic leaves the AWS network to go to an internet endpoint, how the encapsulation and de-encapsulation, if I can call it that, occurs on these Blackfoot edge devices, and how these devices actually send messages to other devices on the network, and how they handle this VPC traffic. It's also a very interesting talk. You can actually see from a virtual machine perspective, the virtual machine doesn't even know that it's part of a virtual private cloud. When when the traffic leaves your network interface, that's when AWS kicks in and actually puts this VPC encapsulation and then references its internal VPC routing tables to determine which physical server, which NIC this traffic needs to be sent to, and then the route and sends it across to that specific physical server. And that server's router, every server in fact has a router on the modern AWS Nitro systems, and these routers basically remove this encapsulation and then pass on the IP packet to the container or the EC2 instance. So I have provided a link to that talk. It's called Another Day, Another Billion Flows. It's a 4 or 5 level talk, and I would highly recommend that you have a look at that talk as well. So every time I think about containers, this thing comes to mind. This is a scene from the Men in Black where all hail Jay. So they are in this. All these people are in a cupboard, or it's like a container basically, and these are resources within the container, and they think, within that container, that's their world basically. Nothing else exists outside of it, sort of. So similarly, when you provision a VPC, within the VPC, resources can speak to each other and so on. But unless you facilitate VPC to VPC communication, you don't really know about the outside world. So resources within the VPC won't know about the other VPCs or others. They are when you create an account, you get some quotas and limits. So you can create 5 VPCs per region. You can create up to 200 subnets per VPC. You can create 5 CIDR blocks and a maximum of 50. And you can have, so these are some quotas and limits that I picked up from the AWS website. What is interesting though is some of these are soft limits. So if you need more, you can always provision more. So I just wanted to illustrate how an availability zone essentially works. So I took two of them. I created a VPC in North Virginia and in Cape Town, and you have one availability zone with the two subnets, a public and private subnet within that availability zone. And in Cape Town, you essentially have a public subnet and a private subnet in 2 different availability zones. And here they are part of the same VPC. Okay, so when I go through the demo part of this webinar, that time I will just walk through how you can create custom routing tables and actually manage access to the public internet and between networks on the VPC. So I will go step by step on how to create a VPC. And then I'll also show you a sample VPC that I created for this webinar in order to illustrate how communication occurs. So what you're seeing here is essentially you have one VPC, you have 2 availability zones, and then you can create public and private subnets. Private subnets would correspond to your more secure networks like your database or application tier or middleware tier that you don't want direct access to the end users to. And then your public tiers would be your web applications, like for example Nginx, Nginx-based web applications. And what you would do is essentially you would create 2 routing tables, and the private subnets would not have access to the internet. If you look at this, you can see that there are 2 routing tables. The first one has each VPC has a CIDR block associated with it. The maximum you can have is /16. That gives you about 65,000 IP addresses. And the minimum you can have is /28. So I will show you how we go about creating CIDR blocks in a VPC. And you can also have 1 primary and 4 secondary VPC CIDRs. So that gives you an ample amount of IP addresses that you can play with, which is a very, it's that amount of flexibility. I mean, even on a physical network, you wouldn't get that with your physical ports and so on. So what you're seeing here essentially is the main routing table. And the main routing table has a /16, so there are 65,000 IP addresses. And the second entry says 0. So if any traffic needs to go outside, then use this interface, the internet gateway, as an interface to route that traffic outside. Now, for the private subnets, you don't want external traffic to come in. So that is why you create a NAT gateway in one of your public subnets. And the reason you need to create a NAT gateway in the public subnets is that you want the NAT gateway to access the internet. Okay, why would you do that essentially? Why would you create a NAT gateway? So the reason you would do that is essentially, say for instance, you have these Linux instances which are running your database server, and you want to update the different instances or versions of RPMs or for that Linux instance. So essentially, you want access to the internet, but you don't want any traffic coming from the internet to be able to access these instances directly. You want it to be coming through the web tier. Okay, so when you provision a VPC, you essentially a subnet within a VPC, you essentially reserve a certain set of IP addresses that you cannot use. So, for example, in this diagram, what you're seeing is in this VPC, I've used a CIDR block of 10.0.0.0/16. So there are 65,000 IP addresses, and then I've created two subnets, a public and a private subnet. Now, /16 means the first 2 octets of the IP address are the network address, and then /24 is that you're subnetting further, basically, to create subnetworks within the CIDR block. And essentially, what you're seeing here is in every subnetwork or subnet, in this case, you would not be able to use these set of IP addresses, and the reason you can't use them is for this. The network address, you cannot use them. So I've used /24. So if you use any other subnet mask, then obviously the network address in that subnet mask will not be usable. You can't use the router address. The DNS address is reserved, and obviously the broadcast, and there is one more IP address reserved for future use. So say for instance you use a /24 or 28 CIDR for your VPC, you will get hardly 11 IP addresses that you can use. That's not very useful. There is one more security consideration, when subnetworking in a VPC, and that is around, you want to avoid using overlapping IP addresses between your on-prem, if you're using a hybrid model, between your on-prem network and the cloud, or between different regions, so that when you are actually peering the connections, you don't have any overlapping address spaces. Okay, so the next thing I wanted to discuss about is security groups. Security groups is a very powerful construct. It is essentially a stateful firewall. So essentially, by virtue of just specifying the incoming port, you can actually automatically the outgoing port is specified. So I will walk through how a security group is configured. So when I get to that point, I will explain it further. So in this example, I will just walk through this example because this is how I've set up a virtual VPC in a specific availability zone, and how I've tiered the VPC. So in a traditional network, especially for customers that have very sensitive information in general, I mean for security purposes, what you normally do is you have, when you VPN, you have a jump box, or it's called a bastion host, or a white box. That term is thrown around quite often. So basically you get into a network where you hop onto a jump box, and then from that jump box you actually hop onto other applications. So the way I've structured the implementation is I've created security groups for the jump box, and then I've only accessed SSH access from other groups from this jump box. So from the internet, you would go to the Bastion host security group using 22, for instance, for SSH access. You can't access the web servers using 22 from the internet, but you can potentially access the web server security group from the Bastion host security group. And it's very similar. So from the Bastion host security group, you can access the application tier and the database tier. Now, say for instance, from the database tier, from the application tier to the database tier, you only want to restrict access. If I'm running, say for instance, a MySQL database, and I only want to access port number 3306. So I would, and that too, I only want to access it from the application tier. I can create a security group from the application tier, and then say only allow access from this security group to this security group. So it's quite a powerful construct from that perspective. So very recently, AWS has been releasing something called the AWS Nitro system. So they are building their own boxes and hypervisors and so on. And they have these very specialized Nitro cards, which reduce the footprint of the or the overhead actually of these virtualization technology on your EC2 instance. So essentially, your EC2 instance does not spend CPU cycles, or the underlying hardware does not spend CPU cycles in order to virtualize. And these specialized Nitro cards for security, for other purposes, there are several of them, even for storage and so on. They enable this offloading of sorts of the encryption, decryption, or of storage and so on. So there is another video on YouTube, the 400 level talks that speaks about this AWS Nitro cards. Okay, so I will cover transit gateways if time permits. I am going to jump to the demo now, quickly. So the first thing I want to show you is how do you go about provisioning a VPC. There is a very simple way to provision a VPC, as well as a very like a visit-driven way, for example. So you, in a visit-driven way, you would actually step through different options, and then you would provision a VPC. So this is a visit-driven way. So you can provision a VPC with a single public subnet, VPC with public and private subnets, or with VPN access. So for example, you want
Roger, sorry,
yes.
Are you sharing your screen there? Because we only see your browser.
Oh, okay. I'm sorry.
Right screen.
Okay. I'm very sorry about it. Okay. Okay. Is it better now? Okay. So okay. So when we go to I'm sorry about that. Let me just go back to the VPC service. On the VPC service, now you can see that you have a launch VPC wizard. This is essentially an easy way to provision a VPC. You can click on launch VPC wizard, and you have these multiple options that you can choose from and provision a VPC. And remember, like I said, VPC is a regional construct. I've currently logged on to Singapore, for instance. I can log on to some other region, for example, North California, and then provision a VPC over there. Then once you provision a VPC, the next step is to provision subnets within that VPC. Sorry, I'm just going to switch back to My screen is slightly, just hold on, I'm just trying to adjust this.
Yes, it's a bit big.
Yeah, I'm just, is it better now?
Yeah, that looks better.
Okay, let me just go back to Singapore because I have provisioned some VPCs there. So let's just go back to the service. What is interesting about cloud infrastructure is infrastructure as code. So essentially, whatever I'm going to do in the next few steps, you can actually automate that. VPCs can be provisioned, for example, for projects. They can be provisioned for environments. So, for example, you can have a CRM project and provision a VPC, or you can have a VPC for dev, prod, or UAT, or you can have subnets within these specific VPC for different environments as well. So there are examples where VPCs are treated as immutable infrastructure. So basically, every time they want to deploy something, they create a new instance and then drain the traffic and move the traffic over to the new instances. And there have been examples of VPCs used in that manner as well. So it depends on your use case, how you want to use the VPC. Every region has a default VPC. If you don't have one, you can always create one, and it has a specific CIDR block. You cannot change that CIDR block. Let me show you that quickly. I've just tagged the default VPC as default. So what I can do is I can delete the default VPC and recreate it. In the past, you couldn't do that. You had to log a support call apparently, but now you can create a default VPC. So you can click on actions and you can say create default VPC, and that essentially creates a default VPC for you. Obviously, because it's a default VPC, that there are not many options that it provides. So, and then like I said, it uses a specific CIDR block as well. And that's the CIDR block it's using 172.31.0.0. AWS services comply to RFC 1918. I just had to pull up the RFC document, and you can see within the RFC document what private subnets are allowed for the private VPC. Sorry about that. So these are the CIDR blocks that are allowed for the private. You can create your own private VPCs, allocate the CIDRs. So what I will do now is I will create another VPC as well. So essentially, I'll go step by step on creating a VPC, creating an internet gateway, and creating one subnet. And then I will walk you through what I've already created, because just in the interest of time, just go quickly through that. Okay. So now if I want to create a VPC, say for example, I'm creating a VPC for the department, maybe, or for a project. So I will just create it for the department. Then I can allocate a CIDR block for it. So I can say 10.10. For example, or 10.50, for example, because I just have some VPC ranges that I'm already using, so I just want to show. At this point, you can select default or dedicated. Like I said earlier, in the past, you couldn't switch from dedicated to default, but from 2017, apparently you can by passing some flags at the command line. Now, for this VPC, now this is the first two octets are the network address, and the remaining are the host address. So let me just show you, just to simplify. What it means. So if you go to cider.xyz and essentially put in the network address and the subnet mask, it will tell you how many usable IPs and so on you'll have. So if you see right at the bottom, it says 65,535 35. Obviously, like I mentioned earlier, you cannot use all of them because there are certain IP reservations, for the VPC, and this is the largest CIDR block you can allocate, and the smallest is 28. And then in the 28 block, you only have 11 usable IP addresses because uh, 5 are used by Amazon for that various purposes. If I put the incorrect net mask, you can see here. Can you see my screen?
Yes. Then see your video, but it's fine. If you want to not share that because of bandwidth, it's fine.
Okay. So if I do get disconnected, I'll probably do. Yeah. So you can see the block sizes are between /16 and /28. So you can't use anything less than /16 and anything greater than /28. So I'm going to just use a CIDR block like so. And then I'm going to just use the default tenancy model. You can always switch at a later point. Okay, so now we have provisioned a VPC. What I'm going to do next is going to provision a subnet within that VPC. Before I do that, I want to show you something else as well. You can allocate, remember the quota constraints that we had. You can allocate up to one primary and multiple secondary blocks of CIDR blocks as well. You can, for instance, add another IPv6 header. So once you run out of your 65,535 IP addresses, if you do run out of that, then you can always allocate more CIDR blocks, up to 5, but that's again a soft limit. So I'm just going to close that. And then once you create a VPC, the next thing you want is, if you want to connect to the internet, that's again an if you want to connect to the internet, then you create an internet gateway and then you attach it to the VPC. If you don't want to connect to the internet, there is no need to do that. After you provision an internet gateway, so basically what you've done until now, let me just reiterate. Is first you just created a logical container and then you said, okay, here is the CIDR block you can use for this logical container. And now what you have done is you have created a internet gateway appliance, and then you have attached that appliance to the, and then what you're going to do is attach that appliance to the VPC. So you can attach only one internet gateway per VPC. So that's why it's not showing the others, because it has already attached an internet gateway. You can't attach more than one. Also, there are no bandwidth constraints on the internet gateway according to the frequently asked questions. The next thing you'll do is once you have provisioned a VPC, you will want to actually create subnets within that VPC so that you can provision resources within that subnet. So essentially, I will just create one subnet and then I will just walk you through what I've already done, so that in the interest of time. So let's just call it SN, and then just for I'll just call it a public. So I'll just put pub, and then I'll say finance, and then say availability zone 1. And then you can choose your VPC in which you want to provision the subnet. So I'll select finance. And now here is the point where you select the availability zone. There is also one interesting thing you need to look at. In order to allow distribution of a healthy distribution of resources across their data centers, what AWS does is the name and the ID, they need not correspond between accounts. So for example, if you were to go tomorrow and create an AWS account, my AP Southeast A1 need not correspond to availability zone 1, it could correspond to availability zone 2. And the reason they do that is there is a tendency to select from the drop-down list the first option that comes to mind. So what would happen in that case is everyone would provision in the same availability zone. So what they're doing essentially here is that they're showing an availability zone and then the ID. What is unique is the ID. So suppose if you have to use your account, you would look at your account, but you would look at this portion, which is ID, and that uniquely identifies that data center. This rotates between the data centers. So that is another thing you need to look at. Now, what I'm doing here is essentially carving out a subnetwork within this CIDR block. So I'll say 10.50. Say, for example, I want to allocate the first network. You can use /16, 17, 18, 20, and so on. I just for simplicity and just for ease of use, I'm going to use /24 because it's just easy for humans to process. So what I'm getting here is 255 IP addresses, but remember 4 or 5 of them are allocated already, so those won't be available. So essentially what I've done here is I've created a public subnet, and in this public subnet, I've allocated one specific subnet block. What you can do then is you can auto-assign IP addresses within that subnet, and you can enable auto-assignment of EC2 instance IP addresses when a user joins that subnet. I'm going to get to that point, and I will show you when that is relevant. Okay. Okay. So now moving back, the next step is once you create a VPC and once you create a subnet, now you want to create EC2 instances within that subnet. Say, for example, you want to create a web server within that subnet and allocate this. So what I normally do is I would create a security group, and then I would provision EC2 instances and attach their interface to that security group. Let me show you an example security group, and then I think I can drive home the point basically. So say, for example, I'm saying finance and web security group, and I want only web access for the security group. And then I choose the VPC. I've chosen the finance VPC. And say, for instance, I want SSH access. Normally for a web, you won't want SSH access. You will want port 80 access. And then say I want it from the internet. Okay, and it's an IPv4 CIDR block. IPv4 address on the internet can access this specific security group. Right at this point, what I've done is I've just created an instance of a stateful firewall, but I have not assigned that instance to anything. So at what point do I assign this security group to that instance? What you would do is, in the past, the security groups option was not under the VPC, it was under the instances. So in the past, you would go to instances, and then on the instances interface, you would essentially select the instance and then assign a security group to that. Before I jump over to the instances interface, I just want to show you all the different security groups that I've created within the CRM VPC. So the first, to start off, I said you would want to create a jump box, and then on that jump box, you would want to just, the users would access that jump box, and then from there jump over to other servers. So it makes sense to have SSH, and suppose if you had Windows servers, then RDP access to that security group. And then you would create multiple EC2 instances which are Windows or Linux based, and then allocate them in that security group. Okay, so that's the first step. Let's go back to the security groups. Now, the second one is, suppose if I create a web security group, But now for the web, I don't want internet access on SSH port. So I don't want to, from the internet, someone should be able to access my web server on port number 22. So what would I do in that case? I would allow internet access on port 80 and 443. Nowadays, nobody allows port 80 as well, so it's only 443. And then what you would do is you would say SSH from port number 22. But what you're doing here is, instead of providing the host, you are providing the security group from which you can jump onto this. So essentially, you're chaining the security groups in a way, and you're allowing access from that. So let me show you. I'm just going to delete that, and I'm saying security. And what you're saying is here, my web servers can only be accessed by um, virtual machines or IP addresses from the Bastion host, virtual machine instances that are part of the Bastion host security group. So that is very profound. And now I'll jump over to the next one. So my middleware tier should be only accessible on port number 22 from the Bastion host security group, and only accessible on port number 8080 where my middleware is listening from the web server security group. So So what you're essentially doing is you're implementing this layered security, wherein you're controlling access to your virtual network in a very similar manner that like you would control access in your physical network, right? So you're essentially layering all this. And in the past, because the security group was under the EC2 instances, it gave the impression that the security group was linked to the EC2 instances. Meanwhile, it wasn't. It was linked to the interfaces. And what you were doing was essentially allowing or allocating the security group to a group of interfaces. So imagine a web server farm, and now by creating a farm of web servers and associating this security group with that farm, you're essentially any web server that is part of the security group will have the same network level access controls implemented for them. So you can create 1, 3, 5, and you don't have to do it on a per server basis. Is it better now?
Yes.
Okay. So now let me just move to EC2 instances to just show you how the security group is associated with the specific instance. I am going to provision a virtual machine, and then when I add it to a security group, automatically all the security rules that are in the security group are enforced. So like I said before, security groups were initially under the EC2 instances. So for this demo, what I've done is I've created a Bastion host, a middleware tier to indicate like a JBoss server or something that is processing EJB code, and then a web tier, which is basically serving static web pages, and a database tier, which is running a MySQL database. That is traditionally how your application would be tiered, basically. Now, what I will do is I will launch an instance. And then as part of the launch process, when it gets to that point, so I select, for example, VPC Finance or VPC CRM. I'll just show you CRM. And then you would select which subnet it would fall in. And by virtue of doing that, you're essentially allocating a random IP address within that subnet, or you can even allocate or customize, specify which IP address you want to allocate, provided you don't allocate those 5 reserved IP addresses. So let's just say this is a web application. So I will select the web subnet. So use subnet setting is auto assign IP addresses. So it will automatically assign IP addresses. I'm just going to breeze through all these other options and just add a tag. I want to show you the part where you come to the security groups, and then you select the security group over here. And that's the point at which you are enforcing the security rules. So if I select the web security group, what you will see is what is applicable as part of that web security group to this instance. So you will have access on IPv4 or IPv6 to port number 80, on IPv4 to port number 443, and you will have access from the Bastion host security group to this to servers in the security. Okay, so what I will do is, while it's busy launching, is go back to the jump box. I will show you how. So I've already provisioned the jump box, so I'll just jump over to the jump box. Now on this jump box, I can access other servers. Like I can jump from this jump box to other servers. So what I've done is I have just made etc static host entries in the file to just show you what were the IP addresses for the previous servers. So I can jump from this jump box, even though the web server has a public IP. Now what you're seeing here is a private IP. I will explain why you're seeing a private IP now, but the web server, you can only jump from the jump box to the web server. Remember the way we structured our security groups. So you can only jump from the web, from the Bastion host to the web server on port number 22. So if I say minus, I think it's 2. So you can see I jumped from, so I'm able to access the web server on that port. Now let me just jump back to the EC2 instances to show you something else. Let me select one of the instances. I will select the ones that have public IP addresses. So these 3 have public IP addresses. And what is doing the translation between the public IP addresses and the private IP addresses? I want to explain that. So if I select the Bastion host, you will also see that it has a private IP address. So this is the public IP address. And if you look at the down here, there is a private IP address as well. Internally within the VPC, all servers are addressed using their private DNS or their private IP addresses. It's not a good practice to use private IP addresses, but from the internet, if you want to access this host, what is facilitating that translation between a public IP address and this private IP address is the internet gateway. So the internet gateway basically maps that private IP address to a public IP address and sends the traffic outbound. And when the traffic comes inbound, it it maps that public IP address back to its private IP address and sends the traffic on its way to the specific instance. So essentially, the instance will never know that it has a public IP address. It's actually the internet gateway that is facilitating that sort of translation between the private and the public IP addresses. The next thing I want to show you is route tables. So if I go back to a VPC, as soon as I provision a VPC, it creates one route table for that VPC. Remember, the router listens on, if I go back to the presentation, the router listens on the first network plus one address. So if it is 10.10.1.0, then 10.10.1.1 would be the router where the router is listening to. And that's why you can't allocate that IP to any EC2 instance within your application. So let me show you with the CRM main how the subnet associations work. So the route table is what facilitates traffic flow. So if I open this, by default, if I didn't have an internet gateway, this wouldn't be provisioned. And even if I did, I would have to manually add a route. So by default, you will get 2 entries in your route table, 2 entries if you use IPv6 while provisioning the VPC. So the first entry is your CIDR block. And what it is saying is any traffic that is designated for the CIDR block routed within the VPC itself. It does not need to go outside anywhere, basically. And it's the same for IPv6. Now, if you want traffic to go out of your VPC to the external network, obviously you need an entry. And what you're saying here is use the internet gateway to route this traffic out of my network. Okay, so what I've done here is I've added that route entry to the main routing table. But remember, I said I don't want any traffic to flow from the internet to my private network. So what I did was I created another route table. In this route table, I did not allow I allowed traffic to flow outbound, but not through the internet gateway, through a NAT gateway that I provisioned. Now, what is a NAT gateway? A NAT gateway allows traffic in one direction, that is from any internal resources to the internet, but not the other way around. So you wouldn't be able to provision, you wouldn't be able to access internal services from the NAT, from the external network. And you can only associate specific route tables with this. So what we have done here is we have associated a route table with the private subnet, and in that route table we have added entries. And now if I want to route traffic to the internet from the private route table, I will add another entry. And here when I add the entry, I will provide the NAT gateway as the endpoint. So what will happen is essentially the NAT gateway will be your exit to the internet. So from the private subnet, if they need to download any software and so on, these database servers will use the NAT gateway to download the packages and the software. So that way, traffic can go outbound, but no traffic can come to these private or the secure network. Okay, so the next thing I wanted to discuss is, so how does this virtual infrastructure look like when it's provisioned using a like infrastructure as code. So basically, you provision a VPC, you provision an internet gateway if you want internet connectivity. Then you attach the gateway, the internet gateway to the VPC. You create bastion host subnets, you create the subnets for all these public and private subnets, and then you start provisioning the resources within that. So by virtue of doing this, you can, whatever I showed you in the last 30-40 minutes, you can actually automate all of that using this service. Rian?
Yes, are you done?
I know we're running out of time, so.
Are you almost done? What do you still want to cover?
I had NACLs in mind, and transit gateways. If anyone would like, we can cover it as part of another extended session, basically. Then I can prepare.
I think maybe if you just want to quickly say what NACLs are and how they differ from security groups.
Yeah, NACLs. Yeah, okay. NACLs apply to the network subnetworks. So the network interfaces, they are stateless. So you would have to define, unlike a security group where you had to define only one-way traffic. For a NACL, you would have to do it inbound and outbound. So and NACLs also use precedence. So you have a allow deny sort of precedence that you specify, and then based on the precedence, it will go through the list in the order in which it is defined, and then process go through that list, and then enforce the security rules. And at the first instance of that rule. That rule statement being valid, it will basically just execute that statement and perform whatever action, whether it's an allow action or a deny action for access to traffic.
Okay, cool. Do you want to do the Q&A now? Are you done?
Yes.
Okay. So I saw a few questions. The first one from Tony. I don't know if you maybe want to unmute yourself and ask them again. Otherwise, I can do it for you. Okay. So Tony was asking, why are public IP siders also usable inside the VPC, since the VPC is supposed to be like a private network?
The VPC needs access. If it's completely private, then you can't consume resources within the VPC. Remember, you're actually serving a business purpose. So essentially, say, for example, you're hosting an application, a cloud-based application that you want consumers to consume. Imagine if everything is private within the VPC, then you would not be able to consume that resource, basically. So that's the reason you need an internet gateway and public IPs within the VPC in order to consume them. In addition to that,
if I could just add to that, it's also because of the routing tables, isn't it? So your public instances know where to route to because of the routing tables, so they can speak inside the VPC.
Correct. So in the main routing table, when I was on that section, I actually added the internet gateway as the outbound path for anything that it doesn't know about. So basically, that's how it knows that it needs to go out, and then it needs to use the internet gateway as an instance. If you do have VPCs that don't have to consume any internet services, and what they have is only private networks. Say, for example, you want to connect from your on-premise network to the cloud. So you want to provision private resources on the cloud. You don't want any access to the internet. Maybe not even a NAT gateway, for instance. You can do that, and then you can create a virtual private gateway, and you can set up a site-to-site VPN connection, and then manage the resources over that VPN connection without it having access to any. So it depends on your use case. So if you think your use case does not need, your resources do not need any access to the internet, then so be it, basically. So you can do
Okay,
it
then
that
there
way.
was another one from Renier. He was asking about this. Like he was asking about SSH access from from the home. So he can't, for example, whitelist everybody's IP address who is working
Yes.
from home. So
Yes,
what's the
that's a very
best
good point.
practice? What would you recommend?
Yes, yes, that's a very good point. Let me, can I just show that quickly? So here, when I'm creating a security group, if you have a static IP, what you can do in the security groups, sorry, I was supposed to be on the VPC page itself. What you can do on the security group is you can allow access from that specific IP, and you can choose my IP there. So for example, let's go to the Bastion host security group. Remember, I said the Bastion host is like a white box, and then you want to jump over to that box. And I only want access from my IP instead of from everywhere. So let me just select that quickly. And then let me edit it. And here you can choose not to allow access from everywhere, but you can choose like from the drop down list, it opens. You can select my IP, and then it picks up your IP, and then basically you only allow access from there. You would have to do that every time if your IP keeps changing, but
So,
okay.
Tony actually he suggested that you can use SSM parameter store to SSH into your boxes, and that is actually a neat way to do it, because then you also control your SSH through your IAM policies of your users. I'll just post a link. So that's one way to do it, or you can also use a VPN service like OpenVPN, where you can just provision a small server key there and do the routing then from there.
I think with last year they also released, first it was only site-to-site VPN. They also released a client VPN connection. So you don't even need to provision your VPN server like OpenIPVSec. You can just consume AWS services and provision a client. It's called a client VPN connection. And you can set up a VPN endpoint on the AWS side and then connect to that as well. Yes, you can do that as well.
Tony, I think you can unmute yourself now. I'm sorry, we were still in the event mode. Do you want to ask your question? Okay, I read it. Tony is asking that he also wants to know what happens in the background when using public-facing ELB in front of a web application. Where you use a public and private subnet, but you put the app in the private subnet. How does this happen?
Okay, the first thing is an ELB is an AWS managed service. AWS uses a component called the AWS hyperplane. So what it does is it allocates AWS instances on the Nitro system or on their existing AWS infrastructure to set up this hyperplane. And they use a concept called shuffle sharding in order to also distribute the load between the instances. So the traffic, so the noisy, to address something called a noisy neighbor problem, wherein you're using shared infrastructure, and then you have another instance on the a customer on the same infrastructure as you, and he's actually bringing down your or he's actually bringing down your or he's causing constraints on your traffic. Now that's not the answer to your question, but the second part is when you use a public, you put a public IP on your load balancer. Essentially, what you're doing is you're telling your internet gateway that route between that the same way as your EC2 instances. to, like I showed you. You have a private IP address for your EC2 instance, and you have your public IP that the internet gateway translates between. And when you use a load balancer just for private, in your private subnet, you're not allocating that public IP. So it is not either routable, or if you have any security groups or any rules around that, it does not allow access to that.
Okay. And then there's another one from Soletu that's asking, in an high availability setup with multiple AZs, would it be necessary to have a NAT gateway on each public subnet? Yes. I saw that there was only one NAT in your diagrams.
Yes, so yes, that is correct. You would have a NAT gateway in every availability zone. So if there is an availability zone-wide failure, for example, say AZ1 and AZ2, if AZ2 goes down and it has the NAT gateway, now you can't actually like perform updates, YAM updates and stuff like that. So yes, it is correct. You have to have one NAT gateway for maximum redundancy. You would have to have one NAT gateway in every AZ, in the public subnet in that AZ. That is correct.
Okay. Anybody else? Any questions? Nothing. Okay. Last chance to fill out that survey.
Renan, one question for Roger. What would be best practice for cloud formations or cloud trails rather to log data with regards to the VPC? So what would you recommend we log so for analysis later? So let's say there's a data breach or any event like that. What would you recommend you log from the start?
What I've read is, unfortunately, I haven't done but what I've read around it is you would use network monitoring tools, and you use mirroring capabilities in order to log traffic, and then you use these security appliances to log all the information so that you can do auditing at a later point in time. Because some of these services don't log all the traffic, the payloads and so on. They only log the metadata around the traffic. So if you want a deep introspection of all your traffic or all your payloads, then you would want to use some of these security services and do some form of port mirroring. So for example, there's VPC flow logs. The VPC flow logs only log metadata. They don't log the payloads itself. So if you want a deep introspection, then my suggestion would be to use one of the security appliances. But I've not really done that, so I wouldn't say.
I can just elaborate on that a bit. So, like what I've seen clients doing, that value security, they do everything within a VPC, and then they enable the flow logs, and then they also enable the VPC endpoints. So now every service has an IP associated to it. So then you can see where your traffic is flowing within your VPC. Like you would be able to know that IP or like that CIDR range means it is going to S3 or it is coming from S3. And then you can get a nice or a reasonably nice picture of how your data is flowing. But it's only going to be like port levels and the size of the packets and like those stuff.
Okay, understood. Thanks, guys.